okay, I would like to work on the first sheet, which is called Group Work Virus 1. So if you would put Group Work Virus 1 in front of you, it should look like this. Okay, the first thing you're going to have to be able to do on this quiz that you're going to see is to be able to determine a rational number that exists between those two numbers right there. Now you'll notice 0.002357 and 0.002358, okay? They are rational numbers. I would like you to find a rational number that's between them. The simplest thing to do to find a rational number between them would be to add them together, as you recall, and divide them by 2. The answer you obtain will be rational and it will be between them. Now, if you take out your phone or a calculator and you put those two numbers in it, this is what you would obtain for an answer. 0.0023575. It would terminate, it would stop. Now, because it stops or terminates, we know that this is what kind of number? Well, it's rational, because rational numbers as decimals either terminate or repeat. This one that you see on the screen has terminated. Could I have made that number repeat? I could have. I could have put a bar over the 5 and told the 5 to keep repeating forever to infinity. That number also is a correct answer for a rational number that is between those two, okay? So you could either put an answer which is a repeater or an answer which terminates just as long as it's between the two numbers that have been given. Remember, the simplest way to get those two numbers, or to get that number between them, is to take the two original numbers, divide them by 2, and write the answer down, okay? Now I want you to look at number 2. If you take your calculator and add those two numbers together, I'll give you a couple seconds to try it, and you divide them by 2, you should obtain 0.048155. Now, that number has stopped. It is not going on your calculator, right? However, we want an irrational number that's between these two numbers, not a rational one. Let me get my picture out of the way up here, okay? So we want a number that's irrational that's between those. Well, there are 3 answers that I would accept. Well, there's a ton of answers I'd accept, but there are 3 number answers that I can show you examples of here, which would be irrational numbers between them. One thing I could do is just put a whole bunch of numbers down after them, after the 5, 5, just so that they're all over the place. And then I could put 3 dots. Now, you don't see any pattern in any of those numbers. You don't see any repetition in any of those numbers. So you could assume that this is a number that goes on to infinity. It never stops, goes on to infinity, but it also never repeats. Therefore, that is an irrational number. So that is one answer that would be acceptable to giving us an irrational number that's between those two numbers. Okay? All right. Now, let me erase what I put on there and go back to the original 5, 5 I got when I divided them. Okay? Another way that I could show that I have an irrational number that's between these would be for me to draw an arrow after it. Whoop, I forgot and left on my eraser here. Let me put the 5, 5 back. If you put an arrow on there, that's a Kellyism, remember. I will count that right. You are telling me by putting that arrow that this number goes on forever and it's all over the place. It's not going to repeat and it's certainly not going to terminate. So I would accept that answer as an answer for an irrational number that's between these two. The third way, and my favorite way to show this answer as an irrational number between them, is to do this. It's to put a pattern on this number. When you put the pattern on this number, it would go something like this. You could do any pattern you want, but I'm going to use a 1, then I'm going to put 5, 5, 5, then I'm going to put another 1, and 3 5s, 4 5s. Now I've established the pattern. See the 1 and 2 5s, then the 1 and 3 5s, then the 1 and 4 5s. If I put 3 dots after this, it tells me that this continues to infinity, and it also tells me the 5s keep growing. That is an irrational pattern and is a correct answer for question number 2. Okay, let's go on. Let's go to question 3. Convert each of the following fractions into their decimal equivalents. You may either use ... notation to do this, or bar notation where necessary. You can use your phone or a calculator to do this, okay? So what I'm going to do is I'm going to bring up the calculator here on this machine, okay? And I'm going to divide these out for you very quickly and show you how we can write the answers. Hopefully it's going to work out. Let's see if the calculator will come up. Okay. Now I believe the first example was, I got to do that over here this way. Okay, I'm going to take 5. Let me clear this out. I'm going to take 5 and divide it by 18 on this calculator. And you'll notice the answer I get is all repeating 7s after the 2. And the 8 on the end, I think you are aware, would be rounded off on this calculator. So we're not going to use that, okay? So we're going to have to realize that this is repeating 7s, okay? So therefore, the answer we would write, okay, for 5 divided by 18 is 0.27 with a bar over the 7. So 0.27, and I can put a bar over the 7 to show the repetition, all right? Or I could do 0.27777 ... It's the same thing as showing what I showed with the bar notation. Okay, now to give myself more room, I'm going to erase the second answer here. How about 5/12? Okay, so if I bring the calculator back up, okay, I can take 5 and divide it by 12. And when I do that, you will see that I obtain 0.416, and then the 6's start repeating, okay? So the answer that is acceptable for the question we just had is to write 0.416 with a bar over the 6. Incidentally, you can't use the Kelly's cheater method to turn that back into the fraction it came from, because that's not a whole repeating chunk. Same thing is true with the letter A up there. I can't use that cheater method to convert that back to 5/18. I just want you to be aware of that. Okay, let's go to C. I can put the whole number down, 9 point. And now what I'm going to do is I'm on my calculator. I am going to divide 3. Let me clear it here. All right. Divided by 22. And when I do that, you can see I get 1 and then 3, 6, 3, 6, 3, 6, 3, 6. So it is 9.1, and then I have the 3 6s are repeating. Notice that that bar should not be over that 1. So let me erase that to make sure you don't get confused by that. The bar is only over the 3 and the 6. Now, if you recall, when you convert the sevenths, and we discussed this in class, the sevenths are 6-digit repeaters. So it's going to be very hard for you to see this on the calculator I have here. But if I divide 1, let me hit clear here, 1 divided by 7, enter. Notice it's 142,857, and then it goes 143. The 3 is actually a 2 on the calculator, but this repeats in a group of 7. So it is 142,857. So this would be negative 4.142857 with a bar over the entire thing, because those 6 digits go on and repeat. Okay, so there's a quick review of dividing fractions out to convert them into decimals. I probably won't even put any of those on the quiz, but I will put ones like number 4 on here. You can use the Kelly's cheater method to convert these back to the fractions they came from. It is really simple, gang. All you got to do is what? Look at how many numbers are repeating, put the whole number out there, and you don't need the decimal point, so I probably should erase that. Okay, so let me put the 5 back down again properly. So it's 5 point. No, I don't need the point. I keep putting it down, but I don't need it. So let me erase it again. I just want the fraction. The fraction is simply, okay, 5 and 72 over 99. Now, you can reduce 72 over 99. It reduces to 8/11ths. And if you take your calculator and divide 8 by 11, okay, you will obtain 0.72 bar, okay? Letter F, you would put the 7 down, and you would put the 315 down over how many nines? Well, it's 3. 4, letter G, it would be negative 2 for your whole number part, and you will put 495 over how many nines? As it turns out, it'll be 4, because this repeats as 0.0495, and again, 0495, 0495, 0495. This answer divided out will give you that repeating decimal. And finally, let's do 3.87 bar. It'll simply be 3 and 87/99. Okay, so there we go. We've got the problems 3 and 4 done. Okay, now you'll recall we did a lot with clock arithmetic or modular arithmetic, and you're going to have to know on the test how to convert or determine the missing letter X in this bank routing number, okay? To do it, you have to use your modular arithmetic knowledge for Mod 10. By the way, there will be no credit cards on this test, and there will be no credit card on the exam. I'm only going to have you deal with bank routing numbers or with UPC codes. No credit cards, so you don't have to worry about those. Now, I will always tell you on the quiz or test or final exam that the code you have to multiply by, this bank routing number by, is 739,739,739. Okay? Now, with that in mind, let's put the 7 39 under here. And let's multiply all the numbers together. All right, we'll get the answers first. Then we'll convert any of the numbers we get into mod 10 numbers. So this is 7x, 27, I usually underline a two-digit number, 45, 21, 21 again, 36, 56, 18, and 0. Now, all the numbers I underlined, I'm going to change to mod 10 numbers. And if you recall, any number in mod 10 arithmetic is the last digit of the number you're looking at. So 27 is simply 7, 45 is 5, 21 is 1, 36 is 6, 56 is 6, and 18 is 8. Now, if you recall, the requirement of any bank routing number is that when you add all its digits together after you've multiplied by 739, 739, 739, and so forth, has to come out 0 mod 10. So we write this equation, 7x, the number we're missing is x, increased by what number has to come out 0 mod 10. All right, I'm going to add the numbers in both directions. Hopefully I'll get the same answer. So 7 and 5 is 12, 13, 14, 20, 26, 34 I got. I'm going to go the other way now and see if I get 34. So 8 and 6 is 14, 20, 21, 22, and 5 is 27, and 7 is 34. Now I have to ask myself, what does 7x, if I multiply 7 times whatever my value of x is, x has to be a one-digit number, what number times 7 will end in what I need to make 34 end in a 0? Well, I think you can see for 34 to end in 0, whatever you multiply 7x to be, or when you multiply it out, it has to end in a 6, because 34 and 6 would be 40, which would be 0 mod 10. So if I have to have 7x end in a 6, what number times 7 ends in a 6? Well, 7 goes into 56 8 times, right? So 56 is the number I need to add to 34, because if x is 8, 7 times 8 would be 56, and 56 added to 34 would be 90, which is 0 mod 10. So therefore, I have correctly figured this answer out. The value x must be in this bank routing number is x equals 8. All right, moving on to the next problem. It says, write the definition of a rational number. I'm going to give you a couple seconds to see if you can write that out. And then I'm going to state it for you again. What you should have written is this. It's any number that can be expressed as the quotient of two integers in the form a over b, where b cannot equal 0. Now, if we go back, I have that written right there. Unfortunately, you probably can't read it. But any number that can be expressed as the quotient of two integers in the form of a over b, b cannot be equal to 0. You know I'm going to ask you this on the quiz, right? So make sure you remember this so you will do well on the quiz. Okay. It says to clearly describe in problem 7 the decimal behavior of an irrational number. Well, if you recall, I'm sorry, I skipped 7. Let's go back to 7. Clearly describe the decimal behavior of a rational number. Well, you can simply write this down. It repeats or it terminates as a decimal. R or T. I'll accept that. That is absolutely correct. So it'll either repeat or it will terminate. 8 says clearly describe the decimal behavior of an irrational number. Okay, so to answer this, you should say the following. It goes on forever. Never repeats or terminates. But if you just say never repeats, that's probably enough, okay? All right, now, please remember that an irrational number can show a pattern. Remember, like 0.26, 266, 2 followed by 3 sixes, 2 followed by 4 sixes to infinity, right? So remember that, okay? It may show a pattern, it does not have to, okay? So you need to know the answers to these two for sure when you take this quiz this weekend, okay? All right, now we're going to take some time to practice a couple problems where I'm asking you to convert them to a different modular system. They're not mod 10s, they're a different modular system, okay? So let's try number 9. First thing we have to do is 8 to the third power, all right? And I believe 8 to the third power is 512. 13 times 5, that is 65, okay? And to do this conversion, what I need to do is add those two together. The answer should be 577. Now I need to convert 577 to a mod 5 number. And if you recall, all you have to do to convert that to a mod 5 number is to divide it by your mod number. Now, I'm going to do it longhand here. Goes once again, and 5 times. You'll notice I have a remainder of 2. Remember, the remainder is your answer. So this number, written as a mod 5 number, 577, when you divide it by 5, it produces a remainder of 2, okay? Since 2 is the remainder, it is the answer. So this answer should be 2 mod 5, not 3 mod 5. So this answer is false. Now remember, I said that you can do this on your calculator, okay? So if you take and work the problem out and use your calculator to do the problem, you could take your 577 here, 577, and divide it by your mod number, 5. Notice you get the whole number, 115. Throw away your decimal. If you simply take the 115 part of it and multiply it by your mod number, 5, you get 575. And if you notice, if I go back to my problem, I got a remainder of 2. What would you get if you subtracted 575 from 577? You would get a remainder of 2. Therefore, I have done this problem correctly. So when you do the test, you may either use a calculator or you can divide them out longhand. Either way. Okay, let's tackle letter B. All right, so I'm going to first on my calculator multiply 8 times 17. So over here, I'm going to do 8 times 17. I got 136. So I'm going to put 136 down here. I'm now going to do 21 times 40 on the calculator. So I will do 21 times 40. And I got 840, okay? So I go back. So this is 840. Now what I need to do is add these two numbers together and then divide by what mod number? I need to divide by 8, correct? Because I want to change it to a mod 8 number. So when I add these together, I believe I get 976. All right? So I'm going to use the calculator to do this. I'm going to take 976 and I'm going to divide it by 8. So I take 976, I divide it by 8, and I obtain 122. Whoa, look at that. It came out even. Now, if it comes out even, what's that telling me? There's no remainder, right? So since there's no remainder, the answer for this problem would be what? It would be 0, okay? So all I have to do is write down, this came out exactly 122. There is no remainder. It is 0. So this should be 0 mod 8. So this is also false. When you take these types of problems and do them on the quiz, you must show your work like this and show me what it is you get for the answer and why the answer is true or false. Okay, what I'm going to do at this point is end this video, all right? So this video will stop at this point and we'll finish up. The second video will finish the first or the second page of this virus group worksheet, 1, and we'll also do the second group worksheet. So you can log in now to the second video.